4.3 is story problems that use these systems that we've been learning to solve. So it's kind of nice because you can see some really basic applications of the math that you've just been doing. So to start out with, this one is kind of simpler than you'll probably see on tests, but it kind of lets you like put your foot in the door slowly. So here we go. A first number is 7 greater than a second number. Twice the first number is 4 more than 3 times the second number. Find the numbers. And that seems kind of overwhelming for your brain to think through, but if we just write 2 equations, we have 2 equations and 2 unknowns, and it's not too bad to solve for. So let's think of our first number. We know we have 2 numbers, and our first one is 7 greater than the second. So we don't know anything about the second, but we know the first one is 7 greater than that, or 7 more, or that number plus 7. So there's our first number, and there's our second number. Now we go to the second sentence. Twice the first number. So I'm going to take 2 times my first number, which is x plus 7. Is, now in math, we should know the word is implies equals. That's our equal sign. 4 more, do you know what that would mean? That means plus 4. And people like to write it first for some reason. I tend to write plus 4 at the end. But we'll write 4 plus something because it's 4 more. Then 3 times the second. So here's our second number. So 3 times the second would be 3x. So what you just did is you used 2 equations and made a system. And this one only has 1 variable. So we can solve for it pretty easily. Read the 2. And then I'm going to go ahead and subtract 2x. And you can do it either way. I'm just choosing to do that to keep my x positive. So I'll have 1x here. And then I'm going to go ahead in that same step and subtract the 4. So I'm going to isolate the variable. So I have x equals, and 14 and negative 4 is 10. So I have x equals 10. So if our first number is 7 greater than the second, then our first number would be 17. And the second number would be the 10. And so on a multiple choice exam, they might say, what's the first number? They typically only ask you one of them, but you can look at those and keep track and know which is which. Alright, let's try the second one. 2 trains leave Tulsa, one traveling north, the other traveling south. After 4 hours, they are 376 miles apart. If one train is traveling 10 miles per hour faster than the other train, what is the speed? Now, there's a couple things in this equation, in this paragraph, that imply an equation. We see miles per hour, and when we see that, we know we're talking about a rate. And we see distances, 376. And we see time, 4 hours. So, do any of you know an equation that relates rates, times, and distances? Some of you are probably saying it. It's distance equals rate times time. So, I have 2 trains. One's going north and one's going south. And they're after 4 hours. So I got a time. I know that they're 4 hours apart. And I know that they're 376 miles apart. But here's the clincher. One train is traveling 10 miles per hour faster than the other. So let's say I have no idea what this rate is. I don't know how fast he's going. But I know this one is going 10 miles per hour distance. I'm going to say that. I'm going to say I have the rate and the time of one train plus the rate and the time of the second train. And one thing I know is different is the rate. But the time is the same. The time is 4 hours. They both are driving for 4 hours. So let's plug in what we know. We know our distance is 376. and we know our time is 4 hours. So I'm going to flip-flop rate and time. Don't let that confuse you. I'm going to write my time first. And then I'm going to times by the rate, which we don't know. And then a rate is the rate plus 10. So that is my setup for this problem. And so now solving this, I'll go ahead again and distribute. So adding like terms, I have 8r plus 40. And then let's subtract 40 from both sides. And since I'm running out of space, I'll do that in my head. And then we know we need to divide by 8, don't we? So dividing by 8, how do I label a rate? Well, we know that our rate was something plus 10 miles per hour. So whatever it is, it's a rate. I'm going 42 miles per hour. And the second train is going 52 miles per hour. All right, let's try the third one. Now this one is the most like ones that I seem to see on final exams and midterms. So it's an important problem. You want to make sure you do this, and when you see one like it, do a second, in thing. You can see percentages like we do in this problem, or you can see dollar signs. So it could be dollars or percentages. Both of those are the common problems. So let's read it together. One solution contains 20% acid. A second solution contains 50% acid. How many ounces of each should be mixed to have 60 ounces of a 30% acid solution? So I'm going to mix my 20% and my 50% in every single problem that I've seen in this course. We're going to write a system. We want two equations with two unknowns. And so with my system, one of the equations is so simple it's easy to overlook. And guess what? That is written right here. How many ounces of each should be mixed to have 60? So I don't know how many ounces of this or how many ounces of this, but I know they need to add up to 60. And they're not the same. I mean, I could have 10 ounces of this and 50 ounces of this. So we're going to say X plus Y, two different amounts, have to add up to 60. And that's the first equation, and that's so easy to overlook. And it's really important. Now the second equation is where we use all the numbers in the problem. So it says I have a 20% solution. So I'm going to use 20%, and we know that we write percent. Percent means, just to remind you, 100. That's what cent is, 100. So 0.2. So for 20% in math, we write 0.2. So I have 0.2 times X amount. I don't know how many, but I have X amount of X ounces. I'm going to add to that 50%. And again, I don't know how many ounces, but it's different, so I'm going to call it Y ounces. And when I combine those, I want them to equal 30%. So I'm going to add 20% to 50%, and I want my total ounces has to be 60. So this is really, it will just be like this every time. It's either a dollar amount times pounds or something like that. A dollar amount times pounds. In our case, it's a percentage times ounces plus a percentage times ounces. I'm going to mix them to equal this percent and this many ounces. And this is called a mixture problem because that's exactly what you're doing, is mixing two different percentages to end up with the one you want. Alright, now I hate decimals, so I'm going to times this equation by 10, and I'm going to do it on both sides of the equal sign, so it won't change anything. I'm just now going to have 2x plus 5y equals 3 times 60. And I'll go ahead and just copy my top equation down. And let's go one more step and multiply 3 times 60. So I have x plus y equals 60, and then I have 2x. Alright, now you can do it by substitution or elimination, whichever one you like. Since we've done less substitution, let's go ahead and do that. So I'm going to go ahead right here and I'm going to solve for this x. So if I solve for that x, I get 60 subtract y, don't I? And then if you remember, when you do substitution, if you solve for x in this equation, you have to plug it in to the other equation. That's big. Times x, which is 60 minus y. And then I've still got plus my 5y, and I've still got equals 180. So we're just plugging this x value into the other equation. So distributing, I have 120 minus 2y plus 5y equals 180. So I wish I had more room. I'm going to 3y. And then let's go ahead and subtract 120 from both sides. And you can see that we get 60. And so dividing by 3, y equals 20. Now it's a story problem, and whenever it's a story problem, we should label it. So what did I just find? 20 what? I have x amount of 50% solution. I know that x plus y equals 60 ounces. So I just found that y is 20 ounces. And make sure you understand that y is by our 50%. So if they ask you, you need 20 ounces of the 50% solution. And if they're going to add up to 60 and you just use 20, that means that you will have 40 ounces of the 20% solution. And that's a rule on that. I think that will get you through the story problems in 4.3, and really focus on the ones where you see a percentage and a dollar sign and you mix them together, because that's the kind you're likely to see on final exams. Good luck.